Hi, mate. Nice to have you here. And
Hello, nice to be here. How are you?
I'm fine. And you?
I'm
Good.
good, thanks very much.
Thank you to be here with us today. I let the stage all for you. Thank you again. See you soon.
Okay, great. All right, hello everyone. My name is Mete Atamel. I am actually dialing in from London, where we started our one month long lockdown again. So thankfully we have events like this where we can talk to people even from home. Today I'm going to be talking to you about serverless containers with Knative and Cloud Run. Normally I do this talk in 1 hour with demos and everything. Today I only have 30 minutes, so it's going to be quick. But I'm going to share you links to many more demos than I will show today. So hopefully you'll have all the information that you need. I also have the presentation on Speaker Deck. I have a blog and I'm on Twitter, so feel free to follow me if you want. All right, so what do we mean by serverless containers? When you look at software development up until recently, you had to make a choice from the beginning. You either went with serverless, so you kind of design your application with small functions that gets triggered with some kind of a trigger. And these serverless frameworks, they were very useful because they kind of abstract away all of the infrastructure from you so that you don't have to worry about where the function is running, how it's auto-scaled, how it's optimized, all that kind of stuff. It's not your worry anymore. You just worry about your function and how it's triggered, and the rest of the stuff is done for you. Because of that, you could iterate fast and you can go fast. So that's why I say, when you go with serverless, you usually have a lot of velocity. You can iterate fast. Now, on the other hand, there are certain times where you cannot use serverless functions. Maybe you want to use a certain language, or maybe you have some kind of limitation in the serverless framework, such as duration time or something like that. Then at that point you have to fall back to something, and usually that fallback is containers. Containers, as you all know probably, is that it's a way to package your application, its dependencies, and its environment into a context that you can replicate everywhere. So this context that you create, it's essentially a runtime that you create yourself, that you define, and you can be sure that that context runs exactly the same way, whether you're running locally or whether you're running in the cloud or anywhere else, right? So I call containers, the thing that gives you flexibility, because basically anything that you can run in a container, you can put it into a container, you can run in a container. So it gives you a lot of flexibility, but then you lose the benefits of serverless. You lose all this abstraction, all this auto-scaling, and all the things that you take granted on serverless. So this was an unfortunate choice that you had to make up until recently, but thankfully now we have projects like Knative and Cloud Run that tries to remove this choice so that you don't have to make this choice anymore. The whole premise of projects like Knative and Cloud Run is to bring the serverless experience to containers. So what I mean by that is that what you deploy in Knative, it's a container, but the way it runs is more like a serverless function. And I'm going to explain what I mean by that as we go along. So Knative, it's an open source project. It was started by Google a couple of years ago, but now companies like IBM, Red Hat, and VMware and others are contributing. So it's out there for anyone to use. It runs anywhere you have Kubernetes. So you can run it on-prem Kubernetes, you can run it in the cloud Kubernetes, you can run it anywhere you have Kubernetes. And it's fully open. It just works anywhere you want to run it. Now, Knative also has managed versions on Google Cloud. So if you're running in Google Cloud and if you want to have a fully managed experience with Knative, then you can use what's called Cloud Run Fully Managed. And this is basically a Knative service that's managed for you by Google's infrastructure. So you don't have to worry about clusters and Kubernetes and all that kind of stuff. Then there's something called Cloud Run on Anthos, which is kind of the middle ground between fully managed Knative and on-prem Knative. It's for those people who want to stay in Kubernetes ecosystem, but who want to also run Knative services on top of Kubernetes. So on Cloud Run on Anthos, you basically get to choose where you run Cloud Run. You can run it in the cloud if you want, or you can run it on-prem as well with GKE on-prem. So it's up to you basically where you want to run it. So as you can see, there's a spectrum of choice when it comes to Knative and Cloud Run. I'm mostly focusing on Knative open source today because that's the one that applies to most places. But everything I talk about today, they also apply to Cloud Run and Cloud Run on Anthos. Now, the Knative stack looks like this. At the bottom layer, you have Kubernetes. That's the platform that runs containers. But as you know, Kubernetes is not serverless. You have nodes, and you need to create pods and deployments and things like that. So that's why you install on top of Kubernetes a gateway, like Istio or Glue or Ambassador. That's a prerequisite for Knative. And the gateway basically figures out how to get traffic to your containers. So how do you connect outside traffic to your containers? So once you have Kubernetes and the gateway, then you can install Knative components. There are two parts of Knative. One is Knative serving, and the other one is Knative eventing. They are separate components, and you can pick and choose. You can use serving only if you want, or you can install serving and eventing at the same time. I'm going to talk about both, but it's up to you which one you need. You don't have to use them both at the same time. So that's Knative open source, and it runs on Kubernetes, anywhere you have Kubernetes. But as I mentioned, there are products that are being built on top of Knative, like Cloud Run. And there are other products from other cloud providers as well. So if you're running on any other cloud, you might want to check to see if there's a Knative implementation that you might want to use on that cloud. Now let's talk about Knative serving first. So what is Knative serving? Knative serving, in a nutshell, it's a way to deploy containers and get them running as if they are serverless functions. I mean, that's how I describe it. So what I mean by that is that, you tell Knative, this is my container, and this is the configuration of my container. Just deploy it, and then Knative figures out the rest. So what Knative does is that it first creates a pod for your container, because as you know, on Kubernetes, you need to create a pod for your container, but Knative does it for you. Then it configures the traffic to that pod. So it sets up Istio if you're using Istio. So it sets up the traffic for that container. So your container is available outside your cluster. Then once your container is up and running, it sets up automatic scaling for you. So by default, you get that. And this automatic scaling, it goes from 0 to n that you define. So your container will run for 60 seconds. And if no one is using your container, it will scale down to 0. And if more people are using it, it will scale up to n that you can define. And then once you have the automatic scaling, you also have this notion of revisions in Knative. So every time you change something about your container or your container's environment, you can deploy a new version, and the new version will get deployed as a new revision. And then you can have multiple revisions of the same service. This is useful for if you want to roll back to a previous revision, or if you want to do traffic splitting, things like that. So this is Knative serving. So in a nutshell, it lets you deploy a container quickly, get it auto-scaled, get network set up for it, and then get a simple configuration, revision management, and traffic splitting with it. Now the Knative serving constructs, they look like this. At the top, you have a Knative service. So that's like the top level thing that you create. Then underneath, every service has a configuration. This configuration points to your container image and your container environment variables, things like that. And then you deploy your service and configuration together. This gives you a revision for your service. And Knative also routes the traffic to that revision by creating what's called a route. Now, every time you change anything with your service, you deploy again, and this will give you another revision. And then the route will be updated to point to that revision. But as I mentioned, once you have multiple revisions, you can change this route as you wish. You can do like A/B testing, or you can do 10% traffic, 90% traffic, whatever you want to do, you can do it. So let me just show you a quick demo of this. Here I am in Google Cloud Platform. I already created a Knative cluster. I already installed Istio. I already installed Knative serving, and also Knative eventing on top. And by the way, I have this GitHub tutorial, Knative tutorial on GitHub where I show a lot of different demos about Knative and how to install it and how to configure it and how to run demos. We won't have time to go through this today, but I'll share this link at the end so you can check it out later if you want. If I go to my console, first, let's look at the pods of Knative serving namespace. This is where Knative serving gets installed. So you can see that my Knative serving pods are running. So Knative is just another app running on top of Kubernetes, and you can see that Knative Eventing is also running, right? So Knative is up and running in my cluster. Now, I want to watch certain things before I create my first Knative service. What I want to do is I want to watch Kubernetes pods, Knative service, configuration, revision, and route. All the things that I talked about with Knative, let's just watch them and see if we have anything. So right now, I don't have anything in my namespace, so there's nothing installed. And then let's go to serving hello world. And then I want to deploy my first service. Now, to deploy my first service, I need to create a YAML file. In Kubernetes world, everything is a YAML. So same with Knative. And in this YAML file, I'm defining my Knative service. You can see that I see my Knative serving. I'm using my Knative serving API. The kind is a service. The name is hello world. The namespace that this will get installed is default namespace. And then this is the configuration of my service. In the configuration, I am pointing to an image. This is a Docker image that I already built and pushed that will basically just say hello world. So it's something simple. And then this is also the environment variable I'm passing in called target, and the version is v1. So our service will read this target, and it will say hello v1. So that's our service. So this is how you define a Knative service and point to a container. So let's actually do that and see what happens. So to create this, I'll just say kubectl apply service v1 YAML. And now this is creating the Knative service. And now you can see that Knative immediately realized that there's a new service. It created a new service for me. It created a configuration for the service. It created the first revision of the service. So this is generation 1, the first revision. It also created a route to point to that revision. And this route has a dummy zip.io domain that I set up for it. So the route is also set up. And you can see that it also created a pod for me. So my container is also running. So all the things that we talked about, it's already created. And if I do a curl to this route URL, you can see that it says hello v1. So our container is up and running. If you ever use Kubernetes directly, Kubernetes and Istio directly, you can see that this is much easier, right? Because all the things that you need to create in Kubernetes with Kubernetes pods and Kubernetes deployments and Kubernetes service, then with Istio, you have to create an Istio gateway and Istio virtual service and connect that virtual service to a Kubernetes service. So all those things that you had to do normally, now we can get rid of that and just create a Knative service and everything is done for you. Now, let's say you want to do a change to our service. So in second version of the service, what I'm doing is I'm just changing this environment variable and changing the version from version 1 to version 2. So I'm doing a configuration change. And let's say in the third version of my service, I'm changing my image. So in this version 3, I'm changing my image from Hello World version 1 to Hello World version 3. And in this version 3, I'm just going to say bye instead of hello. So I'm doing a code change. So let's apply these changes and see what happens and see how Knative handles that. So first thing to point out is that you can see that my pod is terminating. And the reason for this is that the first version, we didn't call it for 60 seconds. So it's scaling down to 0. So it's auto-scaled already. And I didn't have to do anything special for that. It's done for me. So let's apply the second version of our service, service v2. Now, you will see that Knative immediately realized that there's a new version. So it created a new revision for us. This is revision 2. And then it also created a new pod for us. So this is like the pod for the new revision. And then if I do a curl again, now we are back to v2. So we're at version 2. So that's how we can do a code update, a configuration update in Knative. Now, if you want to do a code update, we update our container image. So I built my container and I did an update. Now I applied a change as version 3. And you can see that the revision 3 has been applied as well. And then the pod is set up for that as well. So then if we do a curl again, then it says by v3, right? We did a code update. So you can see how easy it is in Knative to do a change, apply that change, and see that change applied. And then you can do much more complicated things here. But let's say I'm done with the service. I can easily say kubectl delete my Knative service, and the name of my service is hello world. So if I do this, then the service will be deleted, all the configuration, all the revision, all the route, and all the pods will eventually terminate, and then it will go back to where it was. So this is Knative serving in a nutshell. Just to point out, in my tutorial, you can do things like traffic splitting. So you can split traffic between different revisions. You can configure auto-scaling. So right now, the auto-scaling is based on the number of HTTP requests coming in, but you can change that to more like a CPU-based auto-scaling if you want. You can use gRPC with Knative. You can have cluster local services, which is private services, so they're not public, because sometimes you don't want public services, so you can do that as well. And you can integrate with pretty much anything, because you're creating an endpoint, and that endpoint can be called by anyone, really. So you can integrate with Twilio and things like that. So I have tutorials for that. Feel free to check them out, but I will move on to Knative Eventing and show you the second part of Knative. So this is Knative serving. Now, the second part of Knative is called Knative Eventing. And Knative Eventing, it's all about getting different kinds of event sources connected to different event consumers. In this case, event consumers are Knative services, but they can be Kubernetes services as well. And then event sources can be a lot of different kinds of event sources. Knative actually includes a lot of adapters to listen for external events. But these event sources, they can be external to your cluster. So you can read external events into your cluster. Or they can be internal into your cluster as well. So you can have pods within your cluster creating events as well. I should mention that these events are in a format called Cloud Events, which is an open source eventing definition from CNCF. So anyone who can emit these Cloud events can basically be targeted with Knative and can be ingested into Knative and then can be sent to Knative services. And then I should also mention that there's a lot of different ways of getting those events to your consumers. For example, you can connect event sources directly to your event consumers with nothing in the middle, or you can connect it with one-to-many, so you can connect one source to multiple consumers, or you can do, for example, event pipelines where you have multiple sources receiving events, and then they can reply with other events. So there's a lot of things that you can do in the middle. I won't be able to cover them in detail here, but again, I will point you to my tutorial where I talk about all these different details. So that's what Knative Eventing is in a nutshell. Get events into your Knative services. The main building blocks for Knative Eventing, they look like this. First, you install some eventing sources. So these sources, they are the things that read external events into your cluster. And these sources, they're implemented by vendors. So for example, Google Cloud has a separate repo for its eventing source. And then you can read, for example, Google Cloud pops up messages or Google Cloud storage events and things like that into Knative cluster if you want. But then if you are on AWS and you want to read AWS events, there's AWS event sources that you can install into your Knative cluster and get AWS events. So what these sources do is that they read these external events that are in different formats. They're all in different formats depending on what you're reading. And then they convert them into this common format called Cloud Event that I mentioned, right? So they put them into this common format, and then this event then gets into what's called a broker. In Kubernetes, there's this notion of namespaces. So you have a single Kubernetes cluster, and then within the cluster, you create multiple namespaces for different applications. So what you typically do with Knative is that you inject a broker into that namespace, and then that namespace basically becomes available to Knative Eventing, right? So the events can basically flow to that namespace now. So you inject a broker into the namespace, then the broker receives these events that are converted into Cloud events. Then you want to send those messages to different Knative services, and you do that through triggers. So in these triggers, you do two things. First, you connect your broker to a service. So you define which broker you're connecting to what service, and you're also defining what messages to filter, because the broker will receive all sorts of messages, but not all services will want to receive all these messages, right? So in the trigger, you there's a filter section in trigger. There you define what kind of messages each service is interested in, and then the broker will basically send the right type of messages to the right services, right? So event sources, broker, trigger, and Knative services, these are the main building blocks for Knative Eventing. All right, so I won't show you a demo, but I just want to show you the main building blocks on how to set this up. So I have this Hello World eventing demo that I will just go through with you. So let's say we want to inject a broker into our namespace, and let's say we want to deploy a service and connect that broker to the service and make sure that the service gets events. How do we do that in Knative? So I just want to show you that here. First, we make sure that our Knative Eventing is installed, and I think I showed you this earlier. Then you want to label your namespace. So here I'm using kubectl label namespace. This is my namespace name, default. So I'm labeling the default namespace, and the label is Knative dev injection enabled. So when I add this label to my namespace, then a broker gets injected into my namespace. So I can see that if I do kubectl get broker, I can see that a broker is in my namespace. And then broker has a URL. So this URL it's public within the cluster. So it's like cluster URL. And anyone within the cluster, they can send messages to this URL, and broker will route that message. So that's one way of sending messages. The other way is to deploy an event source and then get it that way, but that's not what we're doing here. So that's how we get the broker up and running. Then you need to create an event consumer. In this case, I have an event display, which basically receives the event and just logs it out. So you can take a look at the code if you want in C# or Python. Then I build my image. Then I create my Knative service, just like before. This is a regular Knative service. Then we create a trigger to connect the service to the broker. And the trigger itself that's the interesting part. So the trigger, first, it's if you don't specify the broker. So in here you can specify the broker. If you don't specify, it will look at the broker default broker in the namespace. So that's what this is doing right now. And then this is filtering on event types, event display. So the type of the cloud event, if the type is event display, then this is what will be filtered here. That's what this trigger does. And the subscriber is a Knative service, which is also event display. So that's how we connect event display messages to event display service. So that's the trigger. We apply the trigger. So we create the trigger. Then you see that the trigger talks to the default broker, and it will send the messages to this service. And then to produce the events, you can simply create a pod within your namespace. And then once I have the pod, I get into the pod and I do a curl. And here I'm sending a cloud event here. So the cloud event, by the way, it's nothing more than some headers in your HTTP request. So in here, you can see that I am sending an HTTP post. And then these are cloud event headers. So the ID and the source and things like that. And then this is the body of my event. And the type itself is event display. That's my type that I'm defining. And that's what trigger will use to send the message. So once I do that, the message will go to the broker. And from the broker, it will get sent to the trigger. And then from the trigger, it will get to my Knative service. So I won't show you here, but eventually you will see that your Knative service will receive the event and say, well, you will see this hello Knative message in your logs. So feel free to check this out. I should also mention that on the Knative Eventing, I show how to do simple delivery. So I mentioned that you can connect source to service directly. So that's what I show here. You can do complex delivery with reply. So you can do things like this, where you have source, you have multiple services, and some services can reply back with another message. And then the one that you should really care about is this one, which is broker and trigger delivery. So in this model, that's what I kind of show you. You have your source that sends the messages to the broker in the namespace, and you have services attaching as triggers to the broker, getting events or replying to events. So all these details are on my tutorial. Feel free to check it out, but I will skip here for now in the interest of time. And I also want to point out one last thing before I go. I also built a big data processing pipeline kind of thing using Knative Eventing. So what I do in this pipeline is that, since we're living in a pandemic, I check the news all the time about how many COVID cases there are in the UK, how many COVID cases there are in other countries, and I look at them and I do graphs and look at them once in a while just out of curiosity. So in this pipeline, I kind of do that automatically. What we do here is that I set up a Cloud Scheduler, which is a scheduling service, to call a Knative service. And this Knative service uses some public BigQuery datasets to get the COVID dataset and get some data about certain countries, and then save it into a table. Then it sends a message back to the broker. That message goes to another service called Chart Creator that receives that message and uses this data that we saved to create a chart using matplotlib in Python. Then it saves that image to a bucket, Google Cloud bucket. And then once the image is saved, that triggers an event. And this notifier service uses SendGrid to send me an email. So at the end of the day, every day I get an email that says there are this many cases in United Kingdom, and then I can see the chart. So I built that, and all the details of how that's built and how you can do that with Knative is there. So feel free to check it out. And if you have any feedback, feel free to open an issue or ping me on Twitter. I'll be happy to take a look. But I think I'm out of time now. So I will just leave you with some links. As I mentioned, the presentation is already on Speaker Deck, so check it out. This is the link to GitHub page with my Knative tutorial, and knative.dev is the link for official Knative documentation. And if you're running on Google Cloud, it's much easier to run on Cloud Run because it's managed and you don't have to worry about installing Knative yourself. So I have a separate tutorial for that. Feel free to check it out. And thanks for listening and for your attention, and enjoy the rest of the conference. Thanks very much.
Thank you, Mete, to be here with us today. Thank you for your content and your talk. Very, very beautiful content. I have a lot of feedbacks. And I have a question for you.
Sure.
And the question is, thanks to Knative, we can approach serverless in a transparent way to every cloud provider. There is any reason to keep using cloud provider serverless features like Lambda, Google Action, and so on, if we have Kubernetes, Knative in place?
Yeah, that's a good question. Well, the thing about Knative is that it runs containers, right? Which means that you need to create a Docker file for your application. And you need to be able to containerize your application. That's the only thing that might be challenging for people, because when you compare to, say, AWS Lambda or Cloud Functions, there you just write a function. There's no container to think about. There's no Docker file to think about, and then you just deploy that function. That's much easier than trying to create a Docker file. So that's one thing. And also the Docker file that you're creating and the container that you're creating, it has to adhere to some contract. For example, it has to listen on 000 port 80. It has to, it cannot do background tasks. It has to do everything in the request task. So there's certain limitations that Knative expects your container to do. So you need to adhere to these rules. So those are the two things that come to my mind. Basically, you need to be working in the container environment, and you need to write your containers in a certain way for it to work in Knative. If you can do that, then it gives you a lot of flexibility. And yeah, it will be much more flexible than writing a function, but a little bit more complicated.
Thank you, Mete. Thank you again to be here with us, and see you soon for the roundtable. Thank you again.
Cool. Thanks very much for having me. Have a good day. See you.